Hello everyone and have a good day. My name is Siti Sofea bin Abdurrahman. My matrix number is CD240327. I am a student from Bachelor of Engineering Technology Aircraft Manufacturing from Faculty FKMP. Today I am pleased to present my project, which is a fabrication of glass fiber or polyester composite filled with ceramic concrete waste for molded heavy duty grating. So why is this project is important? First, environmental pollution. Construction waste is often dumped illegally, creating dust and health risks. Second, industrial issues. Traditional gratings are made of metal, which make them heavy, hard to install, and prone to rust. My goal was to see if we could use composite technology to create a lighter, rust-free alternative using recycled waste. So the main focus of the project is to ecological deficit and the second one is mechanical inefficiency. So the first one, ecological deficit, which is from the demolition waste, the ceramic concrete waste that we got from the buildings or any construction can contribute to severe land pollution, agriculture threat, or even a public health risk. And the second one is mechanical inefficiency, which the current heavy duty grating is made up from metal and it is heavy, so hence we make the heavy duty grating by using composite, which we maintain the strength and we make it more lighter than the current heavy duty gratings. So for this project, I had three main goals. First, to study how different amounts of waste filler within 10%, 20%, and 30% affect the material, which is we separate the ceramic and concrete. It is a different powder. And second is to fabricate the grating using molding process. And third one is to test the product to make sure it meets industrial standard, which we want to achieve that it is fire retardant, uh, cannot rust, and it is lighter than a metal grating. Okay, so for this Kikowa grating, we use casting process, which consists of four main ingredients. And for the matrix, we use polyester resin. For reinforcement layer, we choose glass fiber roving so that it is easy to put in the casting mold. And the third one, we use Kikowa as a filler and we choose a different 10%, 20%, and 30% composition of ceramic and concrete powder. And the last one we use MEKP. It is a catalyst so that the product will cure. And the last one we use aluminium trihydrate to make it is fire retardant. Alright, in the making of this project, it process happened in steps. So the first one, we crush the waste into fine powder, which the waste we took from the SW Corp and we collaborate with UPM by using their machine to crush the uh, waste to make it into fine powder, and then we use 3D printing to create a master pattern for the grating. From that pattern, we made a silicone rubber mold, and finally we mix the resin, filler, and layer the glass fiber into the mold and let it cure at room temperature to form the final grating. So to ensure quality, I follow ASTM and ISO standard for the testing, and I perform the first one is flexural test. It is to know how strong the grating is. So the second one is density test to check the weight, and the third one is hardness test, which is to check the surface durability, and the fourth one is water absorption. We want to know how many water that the grating will absorb. And the last one is burning test. Since we include the aluminium trihydrate in the grating, so we want to test it is function or not. This slide shows the flexural strength result for different filler composition. For ceramic waste, the flexural strength increases from 82 megapascal at 10% to 91 megapascal at 30%. For concrete waste, the strength increases from 88 megapascal at 10% to 98 megapascal at 30%. So the highest result is therefore obtained using 30% concrete waste with a flexural strength of 98 megapascal. And based on this result, the 30% concrete waste formulation provides the most acceptable structural performance for heavy duty grading. Alright, so for this slide, we compare the physical characterization between the density and hardness. So the 10% concrete filler formulation produces the lightest overall weight. So this is important because reducing the weight can make the grating easier to install compared to the traditional solid metal alternative. However, the 30% concrete filler formulation produces the highest hardness. So higher hardness can provide better surface durability when the grating is exposed to heavy traffic and industrial environments. So therefore, the project identifies 30% concrete filler as the optimal engineering compromise between weight reduction and surface durability. So this slide focuses on the fire performance of the composite. The objective is to determine whether the composite can resist ignition and reduce fire spread, especially for hazardous industrial applications. So the main fire retardant used is aluminium trihydrate or ATH. When heated, ATH releases water and forms aluminium oxides. This helps suppress combustions. The testing shows that the composite has baseline fire resistance. However, the amount of ATH is very important. If the ATH percentage is not properly controlled, it may have an adverse effect and increase the burning rate. Therefore, the resin to ATH ratio needs to be carefully controlled. Alright, to summarize the project, the Kikoa composite was successfully fabricated into a heavy-duty molded grating. The project also showed that Kikoa can be used as mechanically sound replacement for commercial calcium carbonate filler. The composite provides advantages such as weight reduction and corrosion resistance compared with traditional metal systems. From the environmental perspective, the project converts demolition waste, which normally has little value, into a useful industrial product. This supports the idea of material circularity and sustainability manufacturing. Overall, the Kikowa grating meets the necessary strength requirements while also helping to reduce environmental waste. Alright, for future improvement, there are three main recommendations. So the first one is hybrid metric formulations. Future research can investigate a mixture of ceramic and concrete waste to determine whether it can provide better mechanical performance. Second one is process standardization. The current project use a custom mold. In the future, standard sizing and STM standards can be considered to improve manufacturing consistency and validations. So the third one is chemical optimization of ATH. More research can be conducted to identify the optimum ATH percentage for better flame retardation without affecting the curing of the composite. This improvement can help the Kikoa grating more practical for future industrial application. I think that is the end of my presentation. In conclusion, this project demonstrates that ceramic and concrete demolition waste can be reused as a filler in glass fiber and polyester composite to produce a heavy-duty grating. The project provides both engineering benefits and environmental benefits by producing a lighter, durable product while reducing construction waste. Thank you for listening. I am ready to answer any question in the future. Thank you.